Interpreting environmental test results. A meeting room at EcoTech Industries. Environmental specialist Dr. Sofia Chen is briefing the management team on recent environmental monitoring results. Present are the CEO, Operations Director, and Compliance Manager.
Good morning, everyone. Thank you for joining this briefing on our quarterly environmental test results. Before we dive into the specific data, I'd like to start with some context about how to interpret these results effectively.
That would be helpful, Sophia. I sometimes struggle to understand the significance of all these numbers and technical terms in your reports.
I completely understand. Environmental test results can be challenging to interpret, even for specialists. There are several key principles we should keep in mind when reviewing this data. First, we must understand the regulatory context. Each parameter we measure has specific limits set by regulations. Some limits are absolute. We must not exceed them under any circumstances. Others are guidelines or triggers for further action. When reviewing results, we always compare against these established limits.
How do we know which limits apply to our facility specifically?
That's an excellent question. Our environmental permit specifies exactly which parameters we must monitor and their corresponding limits. I've included a reference table in your briefing materials that shows each parameter, its regulatory limit, and our internal target, which is typically more stringent than the regulatory requirement. The second key principle is understanding measurement uncertainty. No measurement is perfect. All results have some degree of uncertainty. For critical parameters, we must consider this uncertainty when interpreting results, especially those close to regulatory limits. Compliance Manager.
Could you give an example of how measurement uncertainty might affect our interpretation?
Certainly, if our permitted limit for a contaminant is 10 parts per million and our test result is 9.8 parts per million with an uncertainty of plus or minus 0.5 parts per million, the actual value could be anywhere between 9.3 and 10.3 parts per million. This means we cannot confidently say we're below the limit. In such cases, we should take a conservative approach and implement additional controls. The third principle is recognizing trends over time. A single result may be less meaningful than the pattern we observe across multiple measurements. We should be able to identify whether a parameter is stable, increasing, or decreasing over time.
That makes sense. I'm always more concerned about upward trends than individual measurements.
Exactly. Now, let's look at this quarter's results. I'll start with our wastewater discharge parameters, which you can see on page 3 of your handouts. The graph shows our measurements for 5 key parameters over the past 12 months. The red horizontal lines indicate regulatory limits, and the yellow lines show our internal targets. As you can see, most parameters remain well below both our internal targets and regulatory limits. However, I'd like to draw your attention to the total suspended solids, TSS, results, which you can see in the blue line.
I noticed the TSS values have been increasing over the past 3 months. Are we approaching the limit?
You've identified exactly what I wanted to highlight. While we're still below our regulatory limit of 30 milligrams per litre, we've seen a steady increase from 12 milligrams per litre 3 months ago to 23 milligrams per litre in the most recent test. We're now above our internal target of 20 milligrams per litre. This trend may indicate an issue with our filtration system. Based on these results, we should investigate the cause of this increase before we approach the regulatory limit. We cannot allow TSS to exceed 30 milligrams per litre, or we would be in violation of our permit.
What could be causing this increase?
There may be several potential causes. The filtration system could be deteriorating, or we might be seeing changes in our process inputs. It's also possible that recent heavy rainfall has affected influent characteristics. I've scheduled an inspection of the filtration system for next week, and we'll take additional samples to help identify the source. Now, let's move to air emissions on page 4. These results are from our continuous emission monitoring system for the main stack.
The NOx emissions seem to spike periodically. Is that a concern?
Good observation. Those spikes correspond to startup conditions after maintenance shutdowns. Our permit allows for higher emissions during these specific periods, so these excursions are actually permitted. However, we should be able to optimize our startup procedure to reduce these spikes. The important point is that our baseline emissions remain well below limits during normal operations.
What about the particulate matter measurements? They seem to be right at our internal target.
Yes, our PM10 measurements have been consistently around 18 to 20 milligrams per cubic meter, compared to our internal target of 20 milligrams per cubic meter and the regulatory limit of 25 milligrams per cubic meter. While we're compliant, we don't have much margin for error here. We may need to evaluate our dust collection systems to create more buffer.
I notice you've flagged the groundwater monitoring results on page 5. What should we be concerned about there?
The groundwater results show trace amounts of trichloroethylene TCE in monitoring well MW-3, located at the eastern boundary. The concentration is 3 parts per billion, which is below the regulatory action level of 5 PeV, but above our detection limit of 1 PeV. This is particularly notable because we haven't detected TCE in this well previously. We must determine whether this represents a new issue or possibly a laboratory error. I've already requested a resampling of this well, and we should have verification results within 2 weeks.
Could this be coming from the historical contamination at the adjacent property?
That's a possibility we need to investigate. The adjacent property did have TCE contamination, and groundwater flow is generally from east to west. We may be detecting the leading edge of their plume rather than a new release from our facility. We'll need to review historical data from that site and possibly install additional monitoring wells to determine the source.
What action should we take based on all these results?
I recommend the following actions. First, we should investigate the increasing trend in wastewater TSS immediately. The maintenance team will need to inspect the filtration system and identify any necessary repairs or optimizations. Second, we should accelerate our planned evaluation of the dust collection system to create more margin on our particulate emissions. Third, we must follow up on the TCE detection with additional sampling and potentially a focused investigation if the detection is confirmed. We may need to engage our environmental consultant to help determine the source. Finally, I suggest we review our startup procedures to reduce those NOx spikes, even though they're within permitted limits. This would be good practice from both an environmental and efficiency standpoint.
These all sound like reasonable steps. Can you prepare a more detailed action plan with timelines and resource requirements?
Absolutely. I'll have that prepared by the end of the week. One final point I'd like to emphasize. Interpreting environmental data requires both technical understanding and context. Numbers alone don't tell the complete story. We need to consider regulatory requirements, measurement methods, operational conditions, and historical patterns to draw meaningful conclusions. If you have questions about any environmental results in the future, please don't hesitate to ask for clarification. It's critical that we all understand what the data is telling us so we can make informed decisions.
Thank you, Sophia. This has been very helpful. I appreciate the clear explanation of both the results and how we should interpret them.